Hi, welcome to this database management system course with SQL using MySQL. Okay, so what is database? First of all, before studying database management system, we need to study what is database. And even before database, what is the data? Okay, so let me write here data. So, what is a data? A data is characteristic which is usually numerical that is connected through observation. Okay, like anything you can see, anything you can touch, qualitative or quantitative data. What does it mean by qualitative and quantitative data? Quantitative data which you can measure, okay, like those are countable entities, and qualitative data is just describing about the thing. Okay, so this is nothing but quantitative plus quantitative variables. Okay, that's all it is. And the singular of this is datum. Okay, this is not important. And any facts or figures about an entity. Figures is data. Okay, that's all what is data. Now there is one more term which is called information. Okay, what is information? Information is just processed data. Like you have been asked something and you simply take out the thing from the huge chunk of data, and the taken out thing is called processed data. Okay, you did a processing on the data, and then the thing you got, the processed data, is information which is useful. Okay, which is useful for me, taken out from huge chunk of data. This is the simplest definition I can give you about the data. Okay, now what is database? So database is nothing but organized collection of data. That's simple. Organized collection of data, generally stored on computer, obviously. So organized data collection of data is simply database. Now what is database management system? Okay. Database management system. This is nothing but a software which is used to manage database. Manage data, to be more precise. Okay, because database is collection of data and we can manage the data, and it is used to store or modify the data. So the two parts come in this are, you will study it later, but I guess I should tell you about DDN and DML. So what are they? DDN and DML. So DDN and DML is nothing but data definition language and data manipulation language. So these are the two things that we usually do in the database management system. Uh, these are not the things, but these are the language by which we will do the things. Like in SQL, you can create, delete, and these other stuffs come under data definition language. But these comes under data DDL, okay, to be short. And modify, like insert, modify, comes under DML. Okay, simply this is that. I hope you understand what I meant by data definition language and data manipulation language. I am covering in short just for the sake of revision. Okay. So what the next topic is? Okay, so before next topic, I think I should tell you about database management system mode. Okay, so there are many types of DBMS comes in market. Uh, it is a commercial entity. It is a software. Obviously, I told you so. Many companies create their own. Okay, so these are you can use something like MySQL or even Microsoft also gives us something. You can also use Postgres. You can also use like this is not a SQL based data, but yes, MongoDB. Okay, this is a no, not SQL, non-SQL DBMS. Okay, and these were the SQL ones. SQL DBMS. Okay, I hope you understood this. And what is SQL? Okay, so we are doing SQL from a long time. So what is SQL? SQL is nothing but a structured query language. Okay, structured query language. This is the language used to interact with the DBMS. Let me tell you something like you have already some kind of mini data management system already in your computer like MS Excel. You can obviously use MS Excel and I guess you were using it from a long time MS Excel to uh, store the data and make the changes, okay, like pivoting and other stuffs. But what is the need of DBMS? See, whatever MS Excel does, DBMS also does. But DBMS is more scalable than Excel, obviously. And there are also much more functions or commands that I can do on DBMS and not on SQL. Okay, this is a difference between MS Excel and SQL. Also, what we are studying here is RDBMS. Now, what is RDBMS? Relational DBMS. Okay. Now, what is this RDBMS? Let me tell you this with a diagram. Okay. So, small one. This is nothing but a matrix. Make it this is fine, I guess. RDBMS is nothing but a tabular form of the data. Okay, tabular or for mathematics students, matrix form of data. Okay, which we work in rows and columns. Like these are the rows. I think you may know this. These are rows and these are columns. Rows. Okay. These are columns. Okay. So in columns we have our what I can say is data heading, and rows are also called tuples. Okay, so you can name here tuples. Okay, and columns consist of what data type like ID. I can write here ID. I can write here class roll. Okay, roll. I can also write here other stuffs needed to explain here. Okay, so these are the things, and here comes data 1, similarly data 2. Okay, these are other stuffs. Okay, so this is a thing. Now what is the problem with file system? Okay, so as I told you, why you cannot use Excel, because there is a scalability issue, but there are other issues also with Excel. Okay, what are those other issues? This can be asked. So the other issues can be issue with Excel or file systems. One, data redundancy and inconsistency. Now I will explain you everything one by one. Difficulty in accessing data. Data isolation, integrity problems, atomicity problems, concurrent concurrent access anomalies. Okay, so these are the issues that we have with file systems. Now what are these issues? I can explain you everything one by one. So what is data redundancy and inconsistency? Like suppose for two files, if we need to update some data, then it should be updated to both the files. Like the common data, whatever we are updating in one file need to be updated in other file also. Okay, and if not updated, then inconsistency will obviously come. This is called data redundancy and inconsistency problem. Okay, now what is difficulty in accessing data? The access of MS Excel is very limited to few people in the company. Okay, not everyone gets the access of complete data. So there is a difficulty in accessing data that you must request the administrator every time just to get a small bit of information. Okay, this is the other problem that we have with file systems. Now, what is data isolation? So you can understand data isolation as two different types of data, same person in two different files. Okay, like this is similar to data inconsistency. If inconsistency occurs, then isolation occurs. Like the same data is present in two different files. Okay, this is the problem. And what is the integrity problems? Integrity problems is also come due to inconsistency. Like if a person updates a data in one page of the website, but the other page still shows the older data, that is in integrity problems. Okay, now what is atomicity? Atomicity is one of the most important issues, important thing or property, I must say, of a good database management system. What this says, atomicity, either do complete or nothing. This is simply the atomicity. Okay, that you must do either complete thing or nothing. Like I can give you example of online payments. Whenever you make a payment with your UPI, what do you want? That either the complete payment has been gone to the person I am sending the money to, or the money is not get sent completely. It should not be like if you are sending 50 rupees, then 25 rupees goes to the person and 25 rupees comes back to you. Like you want either complete money or whole money back to you. Okay. So this is the atomicity, and this is one of the most important property of the good database management system. Like it is compulsory property of database management system. Every DBMS must provide this, otherwise they will not be considered as a DBMS. Okay. Now, what is concurrent access anomalies? So concurrent access anomalies is like if at the same time two-person are accessing a data, then there will be a clash. Like I can tell you one example of train booking. Okay, train ticket booking. Like if you are booking a ticket on the train of a train and only one ticket is left, then if two-person at the same time, at the same moment, tries to get the ticket, then there will be a clash, and that clash can disturb the database. Okay, so to prevent this, we will also need to handle this. This is handled by DBMS and not with file systems. Okay, these were all the problems with file system which are later improved by DBMS. Okay, now there is one more thing which is instance and schemas. Okay, what are instance? So instance is nothing but collection of information stored in the database at a particular moment. Okay, so simple stored in the database at a particular moment. Simple. This is instance. And what is schema? Schema is nothing but the framework or the design of the database. Data. Okay. Now, what is the view of the database? There is something called view of the database, which we will also study in the SQL. In the SQL, you can get the view of the database. Okay. So it is nothing but the physical or internal level schema describes how the data is stored in the hardware. Okay. Okay, this is physical level view. First of all, I must tell you the physical level view. This is the physical level view. Okay, not the software view, like the not the database view, but a physical view. Okay, physical level view. The view in the SQL is written different. It is the image of the database at a particular moment. Okay, that is simply the view of the database. I will explain it later when we will study the view of the SQL. Okay, so this is nothing but the view or internal level schema. It is a schema describe how the data is stored in the hardware. Schema which describes how the data is stored in the hardware. I guess if you had studied C programming in past, then you have been taught, I hope, that integer takes 4 bit of space. Okay, and that 4 bit of space is at random position in the CPU. But instead, an array of integer, like an integer array in C programming, takes a continuous space of 4 bits at each index. Okay, so this is how it is stored in the database. I can say it is how data is stored in the hardware. The data is stored simply in the linked manner. Okay, as I already told you that this is a relational DBMS, so these all data will be related to each other. Okay, the view will also describe how the data can be accessed. Okay, so the physical level shows the data abstraction at the lowest level and has complex data structures. Only the database administrator operates at this level. Okay, not everyone can operate at this level, because at this level you can access any data and delete any data. Suppose someone who is not much aware of the data access the data, this data like the physical level data, then he gets every right to disturb it, delete it. And suppose if a person deletes every data of the Google, your every Gmail, photos stored in Google Drive, everything gone just in a second. So not everyone gets the right of physical level view of the database. Only the administrator gets a view. Okay, it is simply an abstraction. So I can say that physical level view is the source data, source the data abstraction. Okay. Uh, if you had already studied OOPS, uh, object-oriented programming in C++ or in any language, Java, whatever it is, then you must have studied the four pillars of OOPS, in which one is the abstraction. Okay. And it also has complex data structures. Like it is not a simple array or thing. It is stored in form of graphs or trees. Okay. This was the view of the database. Now there is something also called logical level. Instead of view of the database, I can say you like view of the database is a term, and then I am showing you different views at different levels. Okay. So first the physical level and then the logical level. Okay. Now the logical level. And what is a logical level? This is a level above the physical level. Now here data is stored in the form of entity set, entities and their data types, like the simple SQL thing. Whatever you do in the logical level and the conceptual level. This is also called the conceptual level. Okay. The hardware thing is physical level, the software thing is logical level. This is the best way how I can describe you that. Now what is a view level? Okay, there is something called view level, which I talked about earlier. I thought the view of the database is the view level directly, but this is not the view level. Okay, what is the view level of the database? So the view level is a database where you cannot modify or change anything, but you can only uh, access, not in terms of access, but see the data at that particular instance. Okay, how the data is uh, in the database, like that too, not fully, but only an abstracted form of the whole data, like a small part of whole data which is accessible by you. Only that data can you can see in the view level. Okay. It is a smallest what I can say, smallest view. Okay, smallest level. Or you can also, if like we are going from bottom up approach, so we can say it the highest level of data abstraction, which exhibits only a part of the whole database. Okay, physical level, software part. can be modified. Okay, data can be modified and manipulated. Data can be modified directly. Okay, in the hardware we can directly modify the data. In software part we cannot directly modify data, but we can like modify according to the constraints that are set. Okay, and view level is just the view of the database. We cannot do anything. Just look of the data. Just a look of the data. So this is the whole thing. Now I already talked about instance and schemas. Okay. Okay. So now I think we can go further. This was a just introduction part of DBMS. Okay, this was just an introduction. Now I think we can talk more about in detail. So before going to the ER diagram and the national diagram or the national model or anything, I think we should talk about transactions in database management system. Okay, so transaction in DBMS. I think I should write here introduction of DBMS. Introduction of DBMS. Okay. This is the introduction of the DBMS and this is the transaction of the DBMS. Okay. Okay, leave. I was just playing. Okay. Uh, so this is just a transaction. Just a transaction. Okay. First of all, before knowing what is transaction, let's understand not in terms of DBMS but in general what is a transaction. In general, transaction is where you do transaction mostly, like in payment system and everything. Okay, so that is a transaction. uh, you are asked to give money, you give money, simple. Okay, that is a thing. So now why do we study transaction in DBMS? So according to general computation principle, operating system, okay, we may have partially executed program as the level of atomicity is instruction. That is either instruction is executed completely or not. Uh, you will not be hanging in half. The atomicity I told you, okay. For the atomicity, we do the transaction, okay. When a user performs a logical word or operation, which is always atomic in nature. I told you that atomicity is the compulsory property of the DBMS. Okay, either operation is executed or not executed. There is concept, no concept like partial execution. In this transaction failure, like if you are sending money, then if there's a failure comes, then after the final state of the system, there will be inconsistency, okay, because it will say that the money has been debited from account A but not been credited to the account B. Okay, so this is the inconsistency. Due to this inconsistency, we have to study the transactions, okay, in DBMS. We need to maintain the consistency. Okay. Now, more formally, what is a transaction in DBMS? Okay, so the definition for transaction will be transaction is a set of logically related instruction to perform a logical unit of work. So if I write the definition, then you will understand. I think it's a set of logically related instructions to perform a logical unit of work. Okay. So a transaction is simply a logically related instruction to perform a logical unit of work. What is this logical unit of work? It is nothing but a simple operation. And instruction here I already told you, okay. So this is the definition of transaction. Now, why do we do transaction? Why we do transaction? As I already told you, to maintain the inconsistency, to maintain the consistency, not inconsistency but consistency, okay, to maintain the consistency and consistency simply. And how to ensure consistency? I can say, if before A plus B, like before is a function here, okay, then after it should be same, okay. If it was perfect before, if like I can say, if A has 100 rupees, B has 0 rupees, so before A plus B is 100, then after A plus B must be 100. It should not be like the money is sent but it is not been created, then both will have 0 0, okay. This is the thing why we do transaction, okay, simply this. Then we are only concerned with two operation in DBMS. What are the two operation? I can write here as we are only concerned about read as, write as. Okay. So these are the two operations we are only concerned about. I think you do not, I do not need to define what is read and write operations. Okay. Now there are some desirable properties in DBMS. I already told you some few like atomicity and consistency. What are these? These are also called acid properties. Okay. What are these? Atomicity, consistency, isolation, durability. So with atomicity, consistency and durability, isolation automatically comes. Okay. Isolation is not a separate property. If your system is satisfies atomicity, consistency and durability, then its system automatically satisfies isolation, okay. I can write here like this. Now what I can say, that instead of focusing on the database, now we can focus on the transaction of our data to make our thing consistent, to make our database consistent, okay. So what I can write here is that instead of focusing on the database, like if instead of improving the database and using several properties, we can simply concentrate on the transaction facility for our data to make the database consistent. Okay, remember this. Okay, so what let me now explain on the four properties in detail. Okay, so first is atomicity. What is atomicity? I already told you that either work should be fully done or not done. It should not be in half. A transaction is an atomic unit of processing. You know there is nothing smaller than an atom. In physics and chemistry you must have studied, though there are things, but let's suppose there is nothing smaller than atoms, then you cannot divide atoms. Okay, so if you cannot divide atoms, then that atom should be complete or should not be there completely. Okay, this is why a transaction is an atomic unit of processing. Okay, it should be it should either be performed in its entirety or not performed at all. Okay, I already told you this one before. So now whose responsibility is to maintain the atomicity? So it is responsibility of recovery control manager or transaction control manager of DBMS to ensure atomicity. Okay, now after this I think I can teach you now durability. Okay. I think I said something wrong. I said like if we ensure atomicity, consistency, and durability, then isolation will be ensured, but not. I have mistaken it for consistency. Okay, so if your DBMS is atomicity, has atomicity, isolation, and durability, then it is consistent, obviously, because what is our main goal? To maintain the consistency. So if we have atomicity, isolation, and durability, then automatically consistency will come. Okay, so this was what I wanted to say. Instead I focused more on isolation. I just said isolation. Okay, so I'm correcting my mistake. Kindly correct your notes too. Okay, so now what is isolation? So what is an isolation? That a transaction should appear as though it is being executed in isolation from other transactions. It should not depend on other transactions for it. uh, like other transactions must not affect the current going transaction. Okay, this is the thing. I can give you one more example. Like if I am booking a ticket from IRCTC, then I want the same ticket which I booked. If many people are booking other tickets on IRCTC at the same time, then I don't want that my tickets get exchanged with some other ticket. Okay, this is what isolation is. My transactions should be done isolated from other transactions. Other transactions must not affect my transaction. Okay, Simply this is that. Okay. So this is what isolation is. Now, whose responsibility is to ensure the isolation? Like for the atomicity, we said that it is function of transaction control manager. Then whose function is to maintain the isolation? So it's the responsibility of concurrency control manager of DBMS to ensure isolation. Okay, so this is the thing. I already gave you example of IRCTC, so I don't think I need to give you one more example. Now, what is durability? Like is the fourth property. What is durability? Okay, so now for the durability, what is durability? So in general, durability means long-lasting thing. Okay, but the in transaction thing, durability is nothing but the changes applied to the database by a committed transaction must persist in the database. Or what I can say that data should not be lost, changed on its own. Okay. Also, the data should be recoverable. Simple. Okay. Now, whose responsibility is to manage the durability of the database? Okay. So, it responsibility of the recovery control manager of DBMS. The same which do the atomicity is also performing the durability. Okay. Now consistency, obviously. After studying all the above things, we came final to consistency. Okay. So what is consistency first of all? The preservation of consistency is responsibility of programmers first of all. Okay. Uh, I already told you what is consistency. Like if I can copy here this, simply this is consistency. Okay. Assured all above properties. Consistency will also be ensured automatic on its own. Okay. Okay. So this was the whole acid properties, the very famous acid properties in DBMS. Now next we will study the transaction states. Okay.